This is going to be a quick video recap on hybridization and how to find the hybridization of an atom within a molecule. And remember that hybridization is the blending of native orbitals and combining them into bonding orbitals. So now we have SO3. Basically, we're going to find the hybridization by counting up sigma bonds plus lone pairs. Remember, sigma bonds are going to be the first bond in any multiple bond, as well as any single bond. Another way to do that, if you don't want to talk about sigma bonds plus lone pairs, is that sigma bonds, another way to get those sigma bonds in there is to count up the atoms bonded to the atom in question. So for SO3, if we're talking about the S, the steric number is 3 because it's 3 atoms bonded. Remember that this is a trigonal planar 120-degree bond angle. It is a symmetrical nonpolar molecule. And remember, when we do hybridization, we start with S. We add up to 3 p's because there are 3 p orbitals that can be part of this, and until we get to the steric number. So we have spp, which is sp2 hybridized. That means that the orbitals that are part of the bonding for this molecule, right, which are these ones that I had already highlighted, are a trio of hybrid orbitals made up of an S and 2 p's and then averaged over the 3. For NH3, once again, we're going to count the atoms bonded, 1, 2, 3, or sigma bonds, 1, 2, 3, plus lone pairs. And for N in the NH3, the steric number is 4. Whenever the steric number is 4, again, we start with S. We add up to 3 p's until we get to the steric number. SPPP or SP3 means that the nitrogen is sp3 hybridized. That means that the 3 sigma bonds as well as the lone pair are in orbitals that are a combination and an averaging of 1 s orbital and 3 p orbitals. If I look at NO positive, if I just look at, let's say I'm looking at the N, my nitrogen in this case, the N has 1 atom bonded, 1 lone pair, steric number is 2, sp. Oxygen also would be sp hybridized in this case. Boron in BF3, 1, 2, 3 atoms bonded, which means that my steric number is 3, spp, sp2. If I have a molecule that is bigger, like let's say I have SF6, and I want to know the hybridization of the sulfur, I still do the same thing to get the steric number. The steric number tells me the number of hybrid orbitals. So I have for S, I have a steric number of 6. 1, 2, 3, 4, 5, 6 atoms bonded, no lone pairs, which means again that it is octahedral, it is 90-degree bond angles. We start with S for the hybridization. We add up to 3 p's, that only gets us to 4, and then we can add d's until we get to the steric number. So this is 1 of the hybrid orbitals, this is 3 more, plus 2, gets me to the steric number. Remember, the reason why we can only have one s in my hybridization is because there's only one s orbital per principal energy level. There are 3 p orbitals per principal energy level, and we don't go past a total of 6, which is why we go to 2 ds. Any time you're doing this, again, we are going to add up the sigma bonds, or the total number of atoms bonded on the atom in question, plus the lone pairs. That gives us our steric number. We start with S, we add up to 3 Ps, we add up to 2 Ds. S, P, 3, D, 2 would be a steric number of 6. S, P, 3, D would be 5. SP3 is 4, SP2 is 3, SP is 2.